This is part 2 of the bicycle fork tutorial. In this part, we will learn how to make the sweep that forms the blade of the fork. This sweep is just one feature that comprises multiple steps. I will introduce some terminology that will make this video a little easier to understand. During the course of the video, I'll be referring to the various guides that are going to control the sweep. This guide here I'll refer to as the leading edge of the blade. This is the trailing edge. This edge is the outside of the blade, and this edge is the inside of the blade. Occasionally I will use the term blade and fork interchangeably during the course of this video, so don't let that confuse you. To demonstrate the process for building this sweep, I will toggle to the starter file. We'll assume that you've already inserted into your fork part the bicycle geometry part, along with its sketches and planes that will control the shape of the fork. I've taken the opportunity to hide any planes that are not necessary for this tutorial and any sketches that are not necessary for this tutorial. The sketches we will need are the frame layout sketch, the fork dropout layout, and the important tube diameter sketch. And the plane that we care about is the fork dropout plane, which will control the inside width of the dropouts. Before we go any further, we will add a few planes that are necessary for sketching our fork geometry. We need a plane that will represent the crown of the fork and a plane that will be tilted at the same angle and pass through the axis of the steering tube. So we'll add that right now. We'll select planes. We'll select the front plane as our first reference. For the second reference, we'll select this line in the sketch, and that will give us a tilted plane for the crown. We'll now create a plane through this axis, again through the front plane. For the second reference, we'll select this line. That creates our tilted plane passing through the axis of the steering tube. What we need to do is create two layout sketches for the fork. One will be on the front plane, and the other will be on this tilted plane that passes through the steering axis. I've toggled back to our sweep to show you what sort of curves we need to draw in each sketch. On the front plane, we need to draw a representation of the leading edge, the trailing edge, and the center of the fork, which actually represents both the outside edge and the inside edge. On the plane that's tilted through the steering axis, we need to draw a sketch that represents the outside edge, the inside edge, and the leading edge. But the leading edge and the trailing edge from this viewpoint are directly in alignment with each other, so this single line in the sketch will end up being used twice, once for the leading edge and once for the trailing edge when the projected curves are created. The same will happen with this line in the front view sketch. Will be used twice for the projections, once for the outside edge and once for the inside edge, because these are directly in alignment with each other when viewed from the front. Going back to the starter file, I will now show what the sketch looks like for the front layout. Here I've drawn a sketch for a classic bike fork that has a clean sweep from the crown down to the dropout. I've drawn the leading edge, the trailing edge, and a center line that will end up representing both the outside and the inside edge. This line I've drawn is coincident with the axis of the steering tube. This line is perpendicular to it and passes through the center of the dropout. I've drawn the curves for the blade so that they go down to the center of the dropout and are tangent to a representation of the dropout that I wish to have for my design. You can see I've actually made the dropout a little bit smaller than what was in the original layout sketch. That's okay. This sketch here is just an indicator of the location of the dropout, and if I want to alter the geometry a little bit, I can, but I do need to make sure that the slot for the dropout in the center of the wheel is right where the location of the center of the dropout is in the layout sketch. This particular design is going to have a dropout that blends right into the blade. I've drawn a few lines in my sketch parallel to this line which represent where the dropout will end and where the blade will actually end, which leaves a boundary zone in between that will blend the two together. However, when I do my sweep, I will do the sweep all the way down to the bottom and later on trim off the excess that I don't need. If you want, you can copy the shape of the dropout slot into this sketch as well so that you can turn this layout sketch off and not have to repeatedly refer to it anymore. Now let's take a look at the crown area of the fork. In the crown area, I've drawn a representation of the cross-section of the blade. I made sure that the bottom of this cross-section is going to have ample clearance to the tire. You can also see that this middle guide is ending on the center of the steering tube. I've made my cross-section so it's 25 millimeters tall, 55 millimeters wide, so it's a little bit wider than the crown where it's going to join the head tube of the frame. You'll notice that I've drawn this as an oval, but I've turned this into a construction line rather than solid geometry. The reason for this is I'm putting this in only as a placeholder to remind me of the shape of the cross-section, but I do not want to use it later on as the actual cross-section that will be swept to form the blade. When we get to that step, I'll explain the reasons for this. As I explained earlier, this center line represents both the inside and the outside edge of the blade. The inside edge will only come up to this point of the sweep. The outside edge will come up to this point. So what I did was I just simply made sure that this was long enough so that it will accommodate both guide curves when we get to the point of making our projected curves. So I actually made it go all the way up to the top of the crown, although I probably could have ended it right at this point. Now let's take a look at our front view sketch that will be on the tilted plane passing through the steering tube axis. This sketch represents what the fork looks like from the right view but on a tilted plane. And it has to be properly coordinated with the front view sketch that we were just looking at. In this view, we are drawing a representation of the outside edge of the fork, the inside edge, and the edge that represents both the leading edge and the trailing edge. From this viewpoint, these two edges are directly in alignment with each other. Down at the bottom, at the dropouts, I've drawn a representation of the dropout plate. The inside face of the dropout has to be aligned with the dropout plane. I would make the dropouts about 6 millimeters wide. And I've drawn a representation of the top of the dropout that aligns with the sketch on the front plane. In the bottom, I didn't really bother aligning with anything because it's not important for this particular view. I've also drawn the thickness of the blade from this view, 15 millimeters, which can be different in your fork, but this is fairly typical. I also have a dimension that controls where the inside of the blade is with respect to the inside of the dropout. Some designs have the inside of the blade almost in alignment with the dropout. Others have the overall body of the blade and the overall dropout more centered with each other. So just by changing these numbers, I can adjust the relation of the blade to the dropout. But this face of the dropout always has to be on top of the dropout plane. You can see in this case, I've changed this number to make these a little bit more in center with each other. Here's a case where the inside of the blade and the inside of the dropout are very close to each other. It'll be up to you to decide how you want your blade to look. Let's go back up to the crown. Here at the crown, I drew a representation of the cross-section of the tire to make sure that the blade would not impinge upon it. You can see that the blade is wider up near the crown than it is down at the dropout area. Here I've drawn additional curves that allow the blade to turn the corner and meet up with the front plane. In this view, we have the outside, inside, and the front or trailing / leading edges of the guides. And these have to be drawn in such a way that they meet up with the appropriate points in the front layout sketch. Here we see the outside curve meets this point of our oval cross section, the inside, this point, and the leading / trailing curve meets the center of the oval, which is in alignment with the trailing and leading points in the original front layout sketch. I've also made sure that these curves are horizontal right at the point where they meet the front plane. Now this is a simple blade profile. Yours can be a little different. Some blades actually come down almost straight for a while, flare out in this area, and then continue downward again before they hit the dropout. It's up to you what you want to have in your layout sketch. I'm going to close this sketch. We'll review what we've built so far. What I'll do is turn off these sketches to make it a little easier to see what's going on, as well as this plane. We see we're just left with the two sketches, the front layout, and I'll call it the right layout, but it's on a tilted right plane through the steering axis. And we see how this forms a framework where the important points are coincident with each other between the front and the right layouts. What's going to happen is we're going to repeatedly use these different elements of the layout sketches to create 4 guides. Now remember, in this view, this is the trailing edge. In this view, this is the trailing edge and the leading edge. In this view, here's our leading edge, outside edge, inside edge. By understanding what lines represent what edges in each view, we will be able to do the proper projections in order to get 4 3-dimensional curves.